Welcome back to Bazai. A load balancer sits between clients and back-end instances, distributing requests so no single server gets crushed. Done right, it boosts availability, absorbs failures, and lets capacity scale horizontally without users noticing anything. The trick is choosing the right layer and algorithm for what a load balancer does. Clients hit a single endpoint. The balancer decides which instance should handle each request and monitors health to avoid sending traffic to dead or slow nodes. Because the balancer is the traffic cop, it can also terminate TLS, standardize headers, and enforce policies like rate limits or timeouts before requests have. Layer 4 versus Layer 7. Layer 4 balancers operate at the transport level, IP, TCP, UDP. They're fast and simple. Route based on IP/port, great for raw throughput and protocols that don't need content inspection. Layer 7 balancers look inside HTTP requests, paths, headers, cookies, or even JSON to make smarter decisions. Route/posts to the post service and /comments to the comment service perform A/B canarying or sticky session via cookies. The trade-off is a bit more latency and complexity. Core algorithms. Round robin, the default shuffle, requests rotate across instances evenly. Simple and effective when instances are similar and requests are short-lived. Weighted round robin, give beefier instances a larger share. Handy during mixed hardware migrations or when some pods have more CPU/memory. Least connections, always pick the instance with the fewest active connections, great for long-lived requests or uneven work where some calls are heavy. Hash-based routing. Use a stable hash, client IP, session ID, tenant key, so the same key goes to the same instance. Ideal for stickiness without cookies, multi-tenant sharding, or cache locality. Design choices and pitfalls. Health checks matter. Probe endpoints frequently and remove failing instances quickly. Add outlier detection to drain slow or error-prone nodes before users feel it. Stickiness versus scalability. Sticky sessions can help stateful apps but reduce balancing efficiency. Prefer externalizing state to caches or databases so any instance can serve any request. TLS termination. Offload TLS at the balancer for simpler certops. Re-encrypt to backends if zero trust or compliance demands. Global versus local. Use Anycast plus GeoDNS or global load balancers to steer users to the nearest region. Then local L4/L7 balancers distribute within the cluster. Autoscaling integration. Ensure balancers react to instance churn. Drain connections gracefully during scale down and rollouts. Observability. Capture latency histograms, error rates, and per route saturation. SLOs should alert before head-of-line blocking or queue growth becomes user visible.